Hopefully the framework of this problem is familiar to you. We're given a little bit of information about angle S, that cosine S has this value, and that S is in a quadrant determined by 3 pi over 2 to 2 pi, which would be quadrant 4. But we're asked to find cosine of the half angle, sine of the half angle, and tangent of the half angle. So the framework of the problem is the same, and so some of our process will be similar, but we're just using a different identity. Let's start by finding cosine S over 2, just because it's first in the list. When you have to find more than one thing like this, you want to find the cosine or the sine first, because tangent can easily be found once you know sine and cosine. So cosine S over 2, that identity is plus or minus the square root of 1 plus cosine twice this angle right here, so cosine S, and that's divided by 2. That's just laying out the identity that we're going to use. Now we can go back and substitute. There are two things we need. We need a value for cosine S, which is given right here, and then we need to know plus or minus. And the plus or minus is determined based on what quadrant S over 2 is in. So I know S is in quadrant 4, and it's not enough to just say, well, half of 4 is 2, so it's in quadrant 2. It works out that way in this problem, but it doesn't necessarily work out that way, so you want to be very careful. The way that you figure out the quadrant is to take this inequality for S, 3 pi over 2 is less than S is less than 2 pi, and let's rewrite it for the angle S over 2. To get S over 2, I had to divide S by 2, so that's what I want to do on the other two parts of this inequality. If I divide 3 pi over 2 by 2, then that gives me 3 pi over 4. And if I divide 2 pi by 2, then that gives me pi. So now if I picture that, then 3 pi over 4 is in quadrant 2. It's halfway through quadrant 2 right there. So S over 2 can start right here, and then it can be anywhere between that line and this line right here, which is represented by pi. Now, that's not all of quadrant 2, but it doesn't matter, because all of this section right here, all of those angles, do fall completely in quadrant 2. That tells me that S over 2 is in quadrant 2. And in quadrant 2, the cosine is going to be negative, and that's how you pick the sine. So I'm going to have negative the square root of 1 plus cosine S is given as 2/3 divided by 2. And then I can either get rid of the complex fraction like we did before, multiply the top and bottom by 3 over 3, because that baby denominator is 3, or I can simplify this numerator since it doesn't have any radicals in it, and then get rid of the fractions that way. I'm going to do that. I'm going to simplify the numerator first. If I think of 1 as 3 over 3 so that I have a common denominator in the numerator, then I have 3 over 3 plus 2 over 3, which gives me 5 over 3. Dividing by 2 is the same thing as multiplying by 1/2. So when I simplify that, I have negative square root of 5 over 6. You can take the square root of the numerator and the square root of the denominator separately. Since I'm going to have a square root of 6 in the denominator, I want to multiply top and bottom by the square root of 6. 5 and 6, I'm going to multiply those together. They don't share any factors, and they're not perfect squares, so there's no way that the square root of 30 is going to simplify beyond that. And then when I multiply the square root of 6 times the square root of 6, then I just get 6. Remember that nothing outside the radical can simplify with something inside the radical, so don't be distracted there thinking that that will reduce. It will not. Okay, I deleted my work and I moved the answer up here. This is the answer we just found, just so that we have more room to find the sine S over 2. Keep it all on one page. Sine S over 2 uses a similar identity, plus or minus the square root of 1 minus cosine S divided by 2. Same process. We want to choose plus or minus, determined by whether the sine in quadrant 2 is positive or negative. The sine is positive in quadrant 2. So we get a positive square root, and 1 minus cosine S, given right here as 2/3, and divided by 2. I'm going to simplify first again. So I get the square root of 3 over 3 minus 2 over 3 leaves me 1 over 3. And then dividing by 2 is the same thing as multiplying by 1/2. And when you multiply those fractions under the radical, you get the square root of 1 over 6. You have to rationalize that. That's the same as square root of 1 over the square root of 6. So we're going to multiply top and bottom by the square root of 6. And we end up, I'm going to write this up here, with an answer of square root of 1 times square root of 6 is the square root of 6 over square root of 6 times square root of 6 is 6. Now that we have our sine and our cosine, then the easiest way to find tangent probably is to use tangent s over 2 is equal to sine s over 2 divided by cosine s over 2. As long as these angles are the same, it doesn't matter what they're called, that identity, tangent equals sine over cosine, will work. So I already know the value for sine s over 2. We found it to be square root of 6 over 6, so I'm going to substitute that for the numerator. We found the value for cosine s over 2 to be negative 30, negative square root of 30 divided by 6. The same thing that always happens here. Our baby 6's are going to reduce. Those baby denominators are the same, and they reduce. So I end up with the square root of 6 over negative square root of 30. The same way that you can take the square root of a fraction and take the square root of the numerator and the square root of the denominator separately, you can go backwards if you have a square root on top and a square root on the bottom, and they're both single terms. Then we can rewrite that as a big fraction right here. So I can write 6 over 30. And the advantage there is that I can reduce right here. 6 and 30 reduced by 6 and leaves me 1 over 5. So now I have negative square root of 1/5. That's equal to right there. That's not a multiplication. So now I take the square root of 1 and get 1, and the square root of 5 is in the denominator. If you rationalize 1 over the square root of 5, then you're going to get negative square root of 5 over 5. I just multiplied top and bottom by the square root of 5. And so that's the tangent of that half angle.